We're going to keep our work going with our ellipses today. The first new piece of information we're going to look at, this part is really important here. If an ellipse is centered at the origin, the covertex, the focus, and the origin form a right triangle. So remember, our vertex was our longer direction of our ellipse, our covertex was the shorter version. The focus is that point where that is used to construct our ellipse, and then the origin. Those three form a right triangle. So that helps us with problems like problem 2. We want to figure out, I guess, kind of the other direction. If we have an equation, where are the foci? What are the coordinates of the foci of the ellipse with the equation 36x squared plus 100y squared equals 3600? And then graph the ellipse. First of all, our standard form for an ellipse, for the equation of an ellipse, our x squared plus y squared has to equal 1. So to get this to equal 1, we have to divide our whole equation, each term, by 3,600. That gives us x squared over 100 plus y squared over 36 equals 1. And since my number underneath the x term is bigger, that means that tells us that our ellipse is going to be more horizontal, more like a horizontal oval, I guess. And to figure out where those endpoints are, where our vertices and covertices are, keep in mind that this number, the square root of this number, and the square root of this number tells us our covertices and vertices. So what number squared gives us 100? 10. What number squared gives us 36? 6. And really, to figure out where the foci are, using that fact that a right triangle is formed, we really could use the help of having a picture drawn. Okay, so again, like we said, since this number underneath the x is bigger, our ellipse is more horizontal. 10 and negative 10 are vertices. 6 and negative 6 are our covertices. Now, again, we know that these are our vertices and covertices. If we look at above, the covertex, which is this guy here, the focus, which we don't know where it is, and the origin form a right triangle. These two sides, or these 2 points, and then one other point, wherever our focus is, form together a right triangle. So I'm going to kind of pull that triangle out to the side here. And really, I know that this length is 6. And, well, there's a couple other things we don't really know. However, this hypotenuse of our triangle is also our distance from our origin all the way out to our vertex. So the hypotenuse of our triangle is going to be 10 here. So again, I don't really know exactly where this point is, but the length of my hypotenuse is the same as the length from the origin all the way out to the vertex. So if we use our Pythagorean theorem, a squared plus b squared equals c squared, we can figure out this length and we can figure out where our foci are. So 6 squared is 36. plus b squared equals 100. Means b squared is 64, and my pen's dying on me here. B is at 8 once you square root both sides. So that means my foci are at 8, 0, and at negative 8, 0. So really I should include those on my graph here. 8, 0, and negative 8, 0. And we'll focus at each, and I'm just gonna cross that one off because that is not part of my graph for my ellipse. So we're kind of going the opposite direction here. And I'll do a B example in the next video.